Hello, hello, hello. So, 10.3, number 1. Now, for 10.3, number 1, we need to figure out how efficient our car is. Now, having done your elaborate formula, you have figured out the pressure that your car is supposed to have. You took your brake mean effective pressure, and then you multiplied it by the volume of the engine, and then you multiplied it by your max RPMs. And you know how this is, and you have to remember to divide the volume by 2 because only half the cylinders work, and also divide the volume by 1,000, blah, 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 and of course there's 60 minutes. You know how this works. You've done it. That was, I believe, 10.1, number 4. But I want to see, you get a number. In my case, I got a number 168,210. You get a number. But we want to find out, well, this is what you should be getting. If every cylinder was firing perfectly and every ounce of pressure moved that cylinder and all that force was transmitted to your wheels, that's the amount of power you should be getting. But in reality, you don't get that. In fact, way back in first semester, we looked up the power of your car. I looked at the power of mine. It was only 80,000 watts. So 168,000 theoretically I should be getting. 80,000 is what I do get. So the question is, what is your efficiency? Now, if you'll recall, efficiency is the work done divided by the energy that you put in. Now, I know what you're thinking here. Wait a second, Mr. Merritt. Mr. Merritt, that's power. Power. This is work and energy. Well, remember that power is work or energy done every second. So you could say that the work is the power times the time, right? So in both these cases, it's the power times the time. But you think about it, this is your power times time. This is the power times time. What's your time? It doesn't matter. It doesn't matter because you got time at the top, time at the bottom. Cancel them out. You could just simply look at it that way. So, what do I get? Well, I put this in a calculator and I get 0.47559, blah, 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 blah. Now, you can express efficiency as a decimal, but people usually like to express it as a fraction. So 0.0, we're going to round it to, let's see, 40, well this would be, you could do 47.6. I'm just going to round it to 48%. So 48% efficiency. That means that most of the energy going into my engine is being wasted. Now, that's not really true. This is actually not bad for a gasoline motor. My electric cars tend to be a lot more efficient, but again, I had to mess around and make up numbers in order to get this number because my car doesn't have any cylinders. They don't rotate. Most of the rules that we use just don't apply. By the way, if you are trying to calculate for an electric car, you're going to run into similar problems that, you're going to get some strange numbers. But for a gasoline motor, that's actually a fairly reasonable number. Just bear in mind, you should not be getting a number that's over 1 because you can't be over 100% efficient. So this is actually fairly middle of the road. We've been seeing a lot of numbers like this for gasoline powered cars. With electric cars, because you are kind of fudging some numbers in order to actually even do this, I've had a few people with electric cars get numbers that are over 100%. If that's you, just go with it. Don't worry about it. It's an electric car. You're trying your best. Anyway, thank you very much. I hope you have a nice day. Bye-bye.